So let me introduce to you our speaker, Lukas Taegert-Atkinson. After finishing his PhD in University of Bayreuth, studying mathematical properties of black holes, he decided to switch to his other passion and to something lighter, no pun intended, and do software development. Sorry, I'm nervous. For many years now, he's been a full-stack developer here at TNG with a focus on JavaScript. It's his passion that he shares at his talks and his workshops. When after a talk at Munich Node User group about a JavaScript bundler called RollupJS, he decided to make a few pull requests that significantly improve tree shaking algorithm, or algorithm that removes dead code. Things started moving in unexpected directions. Since 2017, he is a core maintainer and the main driving force behind RollupJS. A tool created by Rich Harris is used for bundling a lot of high-profile JavaScript libraries and is a core, a central component of the web development environment Vite. Please welcome Lukas Taegert-Atkinson.
Thank you, Dennis, for this nice introduction. I think I heard this text before at some point. But Dennis can be very, very entertaining and has a lot of nice stories to tell himself. But today I am the one standing here. And first a question to the audience, just to know you a little more. So who knows what Vite is? Just a show. That is good, but that's not 100%. So just for the people who don't know what Vite is, I think it was in the description shortly, but it's basically, so when you're sending JavaScript to the browser in a front-end web application, you're usually writing many small files, and Vite is one tool to basically make it a nice experience to, that is something. Is a nice tool to basically compress everything together and make your web pages load faster. So who is using Vite? That is a lot of people. That was kind of what I was expecting. Who's using Rollup? Yeah, of course, that was a trick question, and I see you nodding because, you know, of course, if you're using Vite, you're actually using Rollup, and that is kind of one point in this talk. But the most important question to me is any one of you secretly writing or maintaining a JavaScript bundler? I mean, statistically, I would have expected around half a person to one saying yes, because that is basically the whole point of which I'm going to start. So I did some brainstorming before this talk. So let me start like this. 2018, I already held a talk at the big Techday about Rollup, and in this talk, I basically described the whole history of bundling, and there were 3 bundlers, which will be the first 3 in this list over here. But since then, a few things have happened. So these are the bundlers that I know. I'm quite sure there are more. I don't know, has anyone, for instance, heard of this one here? Oh, one. Well, amazing, amazing. Okay, this one has already given up. They joined forces with Vite. This one, that's another story. And this one is here because they have their own bundler because, well, Bun is making everything better and faster. But the one thing most of them have in common, starting with number 3, parcel at the top right, is that most of them are blazingly fast. So some are also lightning fast and incredibly fast, but like all bundlers, like these ones, they're all super duper fast. So, but that's not what I want to talk about today. I want to talk about Rollup, and Rollup is not blazingly fast. I want to make that clear. Maybe at some point it will change, but probably not as quickly as you would hope it to be. So to give you some short history, so it was created in 2015 by, as mentioned, Rich Harris, which is more known for his work on Svelte these days, and some other front-end tool. And in 2017 was my tool. I mean, I mean, it's a story really you cannot tell today. I mean, it started with me making some pull requests, and he said, okay. And then at some point I said, okay, this was easy. So I created a huge pull request saying, okay, I rewrote the tree shaking algorithm because I think this is better. Then there was a little silence, and then I got a message over Twitter actually, saying, so a direct message saying, okay, so here are the access rights to the repository, just merge it yourself. And okay, then I merged it myself because he didn't merge it. So that was that. Then after another 1 or 2 months, I said, okay, do we want to release this? And he said, sure, here are the NPM publishing rights. Why not release it yourself? And this is basically how you can become a maintainer, at least in 2017. Please don't do this at home. Really, I don't know. I don't know if you know the story. Okay, I'm diverging from the topic. So one thing that Rollup really was good at is bundling libraries, which is a weird thing. Why would you bundle a library? The idea is basically you're eliminating a lot of stuff, your library becomes smaller, other tools can consume it more easily, and also in these days, module formats were really in the flow. So Rollup has always supported at least 5 different module formats. At some point, they became 6 different formats, and also it doesn't add a lot of overhead, so this was actually the ideal use case, also very configurable. But of course, bundling libraries is not like where you want to be. Where you want to be is actually web development, because that's where the money is, that's where the interesting stuff is. And yeah, but Rollup is not a big project, so I knew I couldn't maintain a web bundler just because, well, that's the one thing I learned. If you start maintaining stuff, people find bugs, and if you start maintaining something that is successful, people will find a lot of bugs, and suddenly what you really loved, which was solving problems and writing nice algorithms, becomes hard work because you write all day, I don't know, support messages to people. So the best thing that ever could happen happened. So in 2020, Vite was created by Avenue, and he decided that Rollup should be kind of the tool powering the production build, and they basically solved all the issues. They created a nice developer experience, they created the plugins, they created like CSS handling. That's nothing that Rollup really does. So they created all the stuff around this and made it a nice tool. They filtered the bug reports. So I now from time to time get bug reports from the Vite people, and they are really good, well made, stuff that is actionable, cool. Something also to see where is Rollup standing. So I took the browsers you got from the first slide. I removed all the browsers that would look like a flat line here, and there's quite a few that are only remaining. So these are the weekly downloads. As they developed over the last 5 years. So sorry, Parcel, but Parcel was in the flatline category. I didn't expect this. So you can see at the top, probably if you've been in the industry, that's what you expect. That's Webpack, of course. And you see like 2021, 2022, Rollup was really a solid second place. In 2023, it was ES build that was overtaking Rollup for good reasons, because it had found a niche that is much better at Rollup, which is the blazingly fast niche. And then there's Vite. This is the yellow line. Now the interesting thing is Vite has 2 dependencies. One is Rollup, the other is ES build. And then you can do some math and start subtracting the yellow line from the red line, and then we'd see, okay, Rollup is kind of flatlining here if it hadn't been for Vite. So Vite is kind of important for Rollup, at least for my ego, which is also an important part of today's talk. So the question is, what is given to you can be taken from you. So at some point you have to ask yourself, okay, will this stay like this forever? And this was actually so there are 2 points basically that people are criticizing about Vite, and this is the thing I was afraid of, and then basically about Rollup. The first thing is memory consumption. So what Rollup does is basically it loads all the modules it can find, so it follows all the imports. And only after that is done, it's basically does a really cool, I would say, best-of-class code analysis, but this code analysis needs all modules to be in memory simultaneously, not only the code, but really the analyzed structure, so that it can see, okay, this imports that, that has a side effect, so we must include this, and so on. And this means that if your project has a few thousand files, suddenly you need to raise memory limits and need not only megabytes of memory, but maybe gigabytes of memory. At some point, you maybe find out that Node is very good, depending on the operating system, in paging memory. So you can basically say that Node has 5 times the actual memory that your operating system has, and it still kind of works. And not on every system, but at least on mine it does. But still, that's not really a solution. So to fix this, I would probably need to rewrite the algorithm. And rewriting the algorithm would then mean that if I want to keep the same output quality, I need to start paging, like, I don't know, unloading modules, reloading them in memory. So this would make stuff really complex and slow, and that brings me to the second point. Of course, performance is also not so good. I mean, there's a reason everyone wants to be fast, because, well, that's what people do. So, these issues are known for a long time, and last year I finally started, okay, let's tackle this. So what happened in 2023, I actually started to move parts of Rollup to Rust. So I will go into more detail about this. And I created a pull request in July of the same year, so this is it. So you can see it was actually merged then in September, but only on the release branch. It was released in October at ViteConf, because I thought we need to really strengthen this relationship, really. Now the story gets interesting. So in August 23, I got a private message, and I hope Evan Yu is not angry at me. So the message was, hey Lukas, pretty excited to see you exploring Rust and SWC and Rollup. I recently talked to some people working on RSpec, which is another one of the bundlers on the first page, by the way. And we have some interesting ideas. Do you have some time this week or next where we can do a call to discuss it? Now, I don't know if you know Evan Yu. Evan Yu is basically one of the people really living from open source. He's the creator of Vue. He's also the creator of Vite. He's one who's doing lots of talks. And if Evan Yu says he wants to have a chat with you, then you please go to that chat and feel like a very small person and humbled. So I had this chat with Evan Yu, and well, the gist of the chat was that they want to rewrite Rollup in Rust. They have money, they have the people, and they have no interest in what I did so far, which is not what makes you feel good. Okay, I will stop this story at this point because it continues after that, and let's go back to the technical parts. We have something to look forward to at the end. Which is, okay, this is my summary and my reaction. I think this is not the best idea to use kind words. But of course, there's ego at stake, and this tool was created over 8 years, or it was 7 years, and I think it's kind of hard to do this in a short amount of time and get the same output. But let's go back to February. So what was my plan, basically? So I have this tool that all this work has gone into. So this is a very high-level approach how Rollup works. So at the beginning, you are, oh, wrong button. So at the beginning, you're basically figuring out what are the entry points, where you start, then you load all the files. Then this is interesting. So the files are just strings. So what you do is you're parsing them into something called an abstract syntax tree. So it's a semantic representation of the same code. The next step is now you know basically what the code is, but you have to figure out how the code is connected. So you assign variable scopes. So you know, for instance, that a function has its own scope. So you know if x is defined in that function and x is used later, then it's the same x. But if x is defined elsewhere, all these things. So this is really fundamental. Once you have all the connections, then you can do the tree shaking. which is then, okay, and then you find the dependencies and load the other files. When everything is done, there's the tree shaking, you generate some chunks, and you render the output. So, as I'm a consultant, I'm not rewriting, as I already said. So what do? You find the weakest spot, the slowest parts. And the slowest parts are the parsing and the tree shaking. The parsing, but is nothing I've written. I will be honest, I'm using a tool called Acorn, which is a good tool. That's also what Webpack is using. So the idea is, let's start with a part where I have the most uncertainty. Let's replace the parser because, well, I still do not want to write my own parser. I don't have time for this. And then I want to release it, and then gradually just grow the island of native code until it includes the tree shaking. The good thing about this part of the pipeline is there's very little plugin interaction. So plugins are in the JavaScript world. Plugin interaction is bad, but stuff that is isolated, you can then basically move away. And Rollup is really well abstracted. So plugins can only interact at very surgical points. This is very different from Webpack, where basically you can unplug everything. So programmers like this, but maintainers don't like this. So what can you do? So I knew I wanted native code. Native code is fast. There are some options. So there's the obvious option, which would be C++. This will definitely work. Node is written in C++, so this is the tool of choice. Zig, has anyone ever written something in Zig? No, it's super duper cool. That is what Bun is written in, so it must be super blazingly fast. But I had doubts about both the ecosystem and the tooling, so I skipped this one. There is Go. I think Go is probably a solid choice. AS-Build is written in Go, but I didn't want to use Go, because I wanted to, of course, to use Rust, because everyone loves Rust. By the way, a question to the audience. Is someone here because I used the word Rust in the headline? Amazing. That's I don't know why this works, but okay. Yeah, so Rust has some stuff going for itself. So, of course, there is this memory management, and I have 2 slides where I try to explain Rust in 2 slides. Not sure if I can do that. And the second thing is that it's a very nice ecosystem for JavaScript interoperability. I have really the feeling there are some people who really want to make this happen. They really want Rust to be the go-to choice for this kind of stuff, which is good. Like, I'll show you later what tools you could use. And the last thing is that there is SWC, which is yet another one of those bundlers you saw at the beginning. So it's the speedy web compiler, and it's written in Rust. And the nice thing is that basically it's very modularized, and all the modules it's split up are published in the Rust and the Cargo registry. So you can pick the parts of SWC you need. So I could just pick the parser, skip all the rest that I do not want, and have my parser. So that's where I went with. And okay, we are good. We have enough time, right? Okay, so these are the 2 slides I added. I try to explain Rust in 2 slides. And if you don't understand it, forget about it later. So you see, at the top left, this is a struct. A struct is basically what you have as what are classes in other programming languages, except in Rust that the methods are not defined directly on the class, but they are separate. But this doesn't matter. We don't have methods here. So let's say I create a string. This is one way of creating a string that you can manipulate or not. And this is how I instantiate, basically, my struct. So the important detail is on the left side that this keyword mute, which means it's mutable, which is one nice thing about Rust. Everything is immutable by default unless you say it is mutable. So we have a mutable container, and the container contains my string. Now what I do here in the next line is accessing the string in the container, I add something to the string. So I'm changing the string from hello to hello world, and then I'm printing the string. Now the question is, what should happen if I print the original string, the hello? And it's actually a good question. So should it print the original text, hello, but the string is not mutable. The let hello is not mutable. That would violate the assumption that the string never changed. Or should it print hello world? No, sorry. So if it prints hello world, it violates the assumption that it's immutable. But if it prints hello, then in the second line it would need to copy the entire string, which would be inefficient. And to solve this dilemma, Rust just says you are not allowed to do this. So that sounds okay. This is like part one. So in Rust, basically the value, the string, it has an owner. And in the beginning, the owner is the hello. And when I assign it, or when I instantiate the container, the owner changes to the container. And that is one part. And the thing is, this is also how memory management in Rust works, because if the owner goes out of scope, the memory is freed automatically. And this solves a huge headache you have with C++, where you really have to keep track of your memory management. So this is one nice thing. Now the second slide. Because sometimes you do want, for instance, to pass a value to a function or use it in other places. And now we're adding some cryptic symbols here. So this is my struct again, but this time it has an end, a quotation mark, a small letter, and a mut. So the end is something you see very often. It means reference. And if you're coming from other programming languages, just think it means pointer, which is technically what it is. The quotation mark A is something that is called a lifetime, and it's the only important thing about lifetimes is, so if there was a second entry in my struct, which is also a reference, then I could say they have the same lifetime or they have different lifetimes. So it's really not important, but you have to pass them around for housekeeping. And a reference can be mutable and immutable, and this is now independent of the mutability and immutability of the struct. So in the next line, I'm also creating my string as mutable now. Instead of before, I'm creating my container as before, so there's also this end again. And now I can still mutate my container as I could before. Note that the container itself is not mutable this time. It doesn't need to be because the reference is mutable. The reference is kind of disconnected from the container. I can print the container, and I can print the hello, and this works. And what's the magic here? The magic is that this is the last usage of the reference. And after the last usage, so the reference was borrowed, and the borrowing ends here. And now I can do what I want back in the last line again. If I were to switch the last two lines, I would get the compile error again. And everything now checks out. The string was mutable. I could mutate it. Someone else had it in its hands. At no point was it possible to basically mutate the string from different sources. So this was always clear. Basically, that's what I said. One thing I didn't say is that mutable references basically work like read and write locks. So basically, you can have one write lock, but you can have an unlimited number of read locks. And so this is basically how you avoid data races. So that was Rust. And if this was too much, then I apologize. We go back to this topic at hand. So native modules. I mean, I started this, I had no idea. How do native modules actually work? So actually, it's really trivial from a perspective. A native module is just a renamed dynamic library. But what the library is depends on your operating system. So on a Mac, it would be a dilib file. On a Windows, it would be a DLL, and so on. And the traditional way to do this would basically be to use a tool called NodeJib that would recompile the code from C++ every time you installed it. If you have been in the business a little longer, you have seen this. Maybe you run npm install and then suddenly screen after screen of compilation messages show up. But I haven't seen this in years, basically because all tools are using NAPI now, which is something that is a very good idea. So in Node 8, they introduced a stable API that basically means you now building your tools against the stable API. You just specify the API version, then it works across node versions. The only thing is you still need to recompile for every operating system and for every CPU architecture. So that's that. How do you create those files? I mean, I have little time, so I use tools. I think this is the best one I found. So NAPI-RS is, yeah, I think it's the most well-maintained interface between JavaScript and Rust. So how does it work? So this is basically from Rollup itself. So for instance, I have the parse function that I wanted to extract. The parse function is very simple. It has a string argument, so this is a built-in Rust type. It has a Boolean, and the return value is a buffer. The buffer is not a built-in type. The buffer is actually imported from NAPI, and the reason I'm using the buffer is because NAPI then does some magic. So above this function, I have this macro, hash NAPI. And this is an attribute macro. It can basically read the entire code I'm writing, add additional stuff, mutate stuff, whatever. And what it does is does three things. It generates the .node file. It generates JavaScript file that you can basically import. This JavaScript file will import the node file, and it will also do operating system detection for you and the likes, and it generates TypeScript types. And that's why you needed the buffer. Okay, that's one of the reasons why I needed the buffer, so you get a nice buffer type in the output. And this is really a Node.js buffer that it's generating. And they claim it to have the fastest interface, meaning like the most efficient by some comparison, but of course, in the world of blazingly fast tools, who knows how recent this is. I promised WebAssembly, I'm sorry, but I needed to shorten this. So you can do the same for WebAssembly. You switch NAPI-RS for WASM-Pack, but it's basically the same approach. So Rollup is really using those two tools together. And the last question, of course, is how do you publish this monstrosity now? Because really it is a monstrosity, because everyone has a different computer. And this is also kind of solved by NAPI-RS. So the solution is simple. You create a package for every operating system CPU architecture, and they really help you do this. So, and Rollup now has all packages as optional dependencies. So if you wondered what optional dependencies are for, the clue is basically that an optional dependency, when it fails to install, it just doesn't install without a warning. And if it has an operating system or CPU restriction that you do not match, it also doesn't install. So in the end, it basically installs exactly the right package. And if it doesn't do so, by now you get a helpful error that tells you what's wrong. The error says, if you want your computer to be supported, why not contribute? Yes, and there are also scaffold GitHub actions to build all this stuff. This is really helpful because cross-compilation is hard. Some are easy, most are hard. And we now have 16 different targets in Rollup. I think, not sure if there's a package that does many more. Node has a few more, but some are just dysfunctional, like ARM, Linux, older versions. So I don't know. You can run it on Android if you want to. We have 2 Android builds, 9 Linux builds. So that was the theory. So now let's get to the actual work, because of course everything is not that easy and the problems start showing their teeth. You see, I was in my children's room and they had all the dinosaurs here and I needed a nice photo. So the one thing is data transfer. So of course, what do? I mean, I have a crazy idea. I want to rewrite the core parts, but I know it will be a huge undertaking. It will be a lot of work to do this. So what did I do? I started with the absolute minimum to validate the idea. The absolute minimum is basically a hello world's, I don't know, 1 line of code that I want here, converted to the other side, sent over, and measured how much it took. So basically, did some timings. So I did use a larger project than 1 line of code. So the example code I used, it took 180 milliseconds for the old parser to pass. Now putting the same code through SWC in Rust, 51 milliseconds, that's good. It's not 10 times faster, but SWC is not 10 times faster than regular bundles unless you also do all the other steps that, like minification and so on. So, but still, that's like more than 3 times faster. Then I send the stuff over and transfer it over, and then it was suddenly 270 milliseconds, and that is like bad. It means basically I cannot sell this as an improvement because it isn't. So the problem is basically how the stuff is transferred. So when I mean it's transferred as JSON, so what happens? So first, SWC parses the code. It understands 51 milliseconds. Then it goes ahead and takes all the syntax tree nodes and transforms them to small strings, JSON strings. Those JSON strings are then copied over to the memory of the main thread. And in the main thread, you reconstruct JavaScript objects. The JavaScript objects then need to be created. They have a backing instance and so on and so on. There's a lot of work going on, and JSON is just maybe not the right format. So what could be better? And the answer is, well, why not do binary? I mean, it's the only answer I could come up with. What does it mean? JavaScript binary feels like 2 different worlds. So more seasoned programmers will probably know what an array buffer is. So an array buffer is basically the gate to the binary world. It is a JavaScript data structure, but it represents actual memory. You cannot directly access an array buffer, by the way. You can get a view of the array buffer, which is a typed array usually, which sees, okay, this is, for instance, an array of 32-bit integers or whatever. But the thing is, array buffers can just be passed around. So you can pass an array buffer to a native thread and back without copying it. You can pass it to WebAssembly. You can pass it to workers without copying. So that's that. And there's actually a pre-made solution, but of course, I didn't do Googling before. And I think I did something better than that in terms of performance. But if you run into this problem, maybe have a look at MessagePack. I think that's quite cool. But MessagePack is a general solution. So basically, it's kind of a JSON replacement. What I did, of course, is I wrote my own, because at some point, I mean, I'm here for the challenges and the problems. So the challenge is now I want to write something that is much faster. So I have like 130 milliseconds time, and I want to beat 130 milliseconds by serializing and deserializing. So I invented my own binary syntax tree. So some people already did this, and I did Googling here, and what I found, so some years ago, this was a thing, binary ASD, and what I found is just some prototypes and stuff that didn't work, and that was just not production ready. So no help here. The problem is, of course, you have 2 worlds. You have the Rust world, the JavaScript world. You have to connect them somehow. And you have to do it in a way that it's not a real pain to write all this stuff. So what I did is, in the end, code generation. So I start with a single file. This is basically what it looks like. It's a long list of AST nodes, and just says, okay, these are the first 2. Then array expression has a field of elements, and I say it's a node list, which is something I made up. And an assignment pattern has a left and a right node. So that's basically what's written in this file, and a few more things. And using that file, I then auto-generate a JavaScript decoders. And they are actually quite simple. So they have 2 parts. There's a common function, which is convert node, that just converts any node. It gets 2 arguments. The first is the position in the buffer, and the second is the buffer. You see the buffer now has a different type. It's no longer buffer. It's uint32 array. This is one version of a typed array, which means my buffer is structured as 32-bit integers. And then I say, okay, the type of the node is just the number at the very first position. Because, I mean, in the syntax tree, it's strings, but switching strings to numbers has a nice advantage. It has a disadvantage. You have to keep the numbers in sync, but the advantage is now you can use it as an array index, the number. And this is the second part, is basically an array of converters. And this array of converters is also completely auto-generated, so that the numbers are all in sync. And because this array is created in one go, I'm really helping the JavaScript engine here. So it can really optimize the array and can write native code that basically just takes the number and calculates the memory position where the decoder is. And looking at the decoder, so basically this is creating a JavaScript object as it's usually looks like, and you see the elements. So there's a helper function that decomposes the list of nodes. And there are some positions, like here at position +1 is the end, at position +2 is elements. So this is also something that needs to be kept in sync. So what does it look like on the Rust side? To be honest, I didn't start this way. I started by writing manual encoders and decoders. And then after I had some and had my hello world, I looked at what is the same and what is different, and then evolved the concept. So the latest thing on the Rust side is actually to auto-generate macros, because SWC is really not standards aligned with that syntax tree. So it's a two-part process. So again, you see a struct. So the struct is now here that what keeps my data. It has a buffer, which is the buffer I'm generating when encoding, and there's an index converter. I'll not do anything in here on this slide. It's just so you know, another challenge is that Rust is using UTF-8 strings and JavaScript is using UTF-16 strings. And this wouldn't be a problem if Rollup didn't heavily rely on string positions or rather byte positions or positions in string. And string positions are very different between UTF-8 and UTF-16 as soon as someone uses an emoji or an umlaut or some other weird character that is, well, different. That took me a while to figure out, and that really hurt. That's like the moments when you have a great idea and you stumble upon those small things and say, can I keep going? But that's why I didn't tell anyone before I was doing this, because that reduces the pressure. Now the thing is, in the macro version, it looks really nice. Basically, this is the macro. You see it by the exclamation mark at the end. So there's a macro store array expression. It always gets the buffer. Then this is like in macros. In Rust macros, you can invent syntax. So the syntax I invented is I use arrows. On the left side, you see the entries that the node has. So there's some checking if I'm generating the right stuff. And so the span is basically start and end. And the elements are used, so those bracket syntax, it means the elements are picked from array literal elements. And for every element, it should call the function, the method convert expression or spread. This is also implemented somewhere on the struct, somewhere else. Which is also something cool, by the way, about Rust, that you can have a class that is spread over 100 files if you want to. So basically, you have one file where the struct is, but 100 implementation files that implement different parts on the struct, which is something that I went up using. Not sure if this is best practice, but it felt right. So where did we come up? So we're starting with 180 milliseconds and 51 milliseconds time. So the serialization was fast, 8 milliseconds. That was good. That felt really good. Deserialize was slower, but we got to 47 milliseconds with this new approach. So in the end, and there's some losses in between, 108 milliseconds, which is good. So we are really faster, like a third, more than a third faster than before. That is a good start. Compare this to the other time. But we gained much more. Because we never talked about multi-threading yet. This is always what people say, oh, did you think about using more threads, workers, and whatnot? So the thing is, JavaScript workers are a pain. They are excruciatingly slow. It's okay to use a worker if you write a server that runs all day, or if you have a really web application where people stay like for minutes. But starting up a worker is less. It takes macroscopic times, and if you have a command line tool, then it's just super duper slow. Because I don't know why. It's just the way it is. But Rust has the ability to just start threads, and threads are basically free. I mean, if you're coming from a Java world, you know, hey, I want a thread, I get a thread, here it is. And that's basically also what you have in Rust. So I could just put all this decoding logic in a separate thread, and so from the 108 milliseconds, 51 milliseconds, I can completely subtract. This is just my win. So actually, I went from 180 milliseconds down to 47 milliseconds. Now this begins to sound interesting. And there is more. Okay, in WebAssembly this doesn't work because WebAssembly does not really support threads yet, and all implementations that I saw use workers under the hood, so they are bad. But another thing I can do is basically I don't need the JSON. I just created the JSON because there always was the JSON. Rollup uses internal data structures, so the next step was not generating the JSON, but directly generating the internal data structures. So we can also get rid of the 47 milliseconds. And in the end, where we are now with this approach is that we are really 20% faster all end-to-end. So I did a measurement, that's basically where we are now, roughly 20% faster. It's not super fast, but really, the tree shaking is missing. The tree shaking is not the only really slow part. So, where does this go? So one question I was asked is, do you think it's really a good idea these buffers put all the work in? I mean, the goal is to convert everything to Rust, isn't it? And I said, no. It's not stupid. And there are some parts I'm really proud of. I have no idea how I would do this in Rust and why they're working well and they are fast. Like the code splitting, I could tell you another story about this, but it's already a really technical talk. I spare you this. So, in short, we stick with the buffers. The buffers are good. The buffers have some advantages. For once, I can write a buffer to disk and read a buffer to disk basically instantly. I can pass them around. And I can access them from JavaScript and Rust, just the way I did it with auto-generated code. So the end goal is actually, so the JavaScript parts that I'm not rewriting, that those are basically directly working on the buffer. This is a long-term goal, but let's see where we're getting. But there's something else, something interesting. I'm getting to the end of the technical part. Because I still have the JavaScript plugins. And well, I really want, and also in the future, people to be able to write plugins in JavaScript, but those plugins should be faster than before. And one thing that plugins also need is to figure out what are the imports of a file, what are the exports. So what I'm currently working on, and it's not quite finished, but it's already progressing. And if I hadn't created this talk, maybe it would be finished. But is an API to basically give plugins, so the plugins can say, okay, I'm only interested in imports, give me all imports, and then my algorithm just walks over the buffer, figures out the imports, and when it finds an import, it just generates them as needed, the AST nodes. And the AST nodes are not only generated lazily, they're also using getters for all child nodes. This is already implemented, not released, but implemented, so that basically it really does the absolute minimum to give the plugin what it needs. And my hope is that this will be a lot faster, but let's see. Maybe I will report at some point that it's amazing, especially for the CommonJS plugin that really heavily relies on this, and I hate the CommonJS plugin, but it's a necessity, unfortunately. The other thing is that that is something that nobody has done before, and people noticed that. So I was to the JS Craft Camp lately. So that's a small, like, unconference, barcamp style thing. And there were people from Dino, that you may know, it's the alternative to Node framework, so really engineers. People I actually knew, and it's like this kind of thing, you're talking to a person like for half an hour, and then the name badge was always turned the wrong way, and then I see, oh, it's you. Okay. Oh, you're actually quite nice. I didn't know that. Nicely talking. And they tell you, like the people that in your personal world are somewhere up here, the people doing the stuff, and they tell you, oh, we've been reading your code really interestedly, and we find your ideas very interesting. Oh, okay, you're reading my code. No? Didn't expect this. I would have taken more care if I had known that. And actually, so the thing is, Dino is written in Rust, which I was not really aware of. Flo probably would have been aware of this. But the thing is, so Dino is also integrating more tools. For instance, they want to have their own linting solution, and they want their linter to have plugins. And this is the main problem. So a linter plugin needs access to the syntax tree. And they have a huge pain getting the syntax tree from the Rust world into the JavaScript world for the JavaScript plugins, and hooray, that is a problem I'm currently solving. So this was a great idea going to that conference. Let's see if I can deliver on this, but it was very nice. So that's the end of the technical part, because I said I started a story in the beginning. I wanted to end with a story. So the thing is, in August, Avenue actually offered me to pay me for work on this. Okay, it's not how it worked. It was like, can I join? And he said, sure, but I don't have time for this. Can you pay me for this? Oh, well, yes, we can make you a contract for I don't know what. Okay, but I want to stick with my current employee. Can you do it as? And so the end result, yes, sure, no problem. But still, so actually, I mean, the danger is real. They really wanted to take like the fame of Vite away from me, so I said, no problem. I really go all in. That's why I'm actually changed clothes to say yes. Sure, take me. And so I did something I'm not sure I should have done. So at ViteConf, where I also released the new Rollup version, I said, okay, really, if rolldown matches Rollup, then let's rename rolldown to Rollup and scrap Rollup. That was that. Then nothing happened for a very long time. Well, something happened. I got apparently early access to the rolldown repository, so which is the Rollup replacement, rolldown. Very funny. That was nice, but really, I don't know. I don't have time to look into this. I mean, I need time for this, so that's what my problem is. I mean, I have a job. So one other thing, completely unrelated, but something I should have done before, is that in March I finally started offering workshops to say, okay, like, I don't know, why not teach people at my own company about this? Is someone here from those people? No, that's good. Okay. We didn't get as far as I hoped would be, and I completely overwhelmed them, but it was a nice experience. It taught me a lot about the usability and the beginner friendliness of the code base, and kickstarted actually something nice. So, okay, I don't want to make promises of stuff that will never happen. Let's say what we are going to release really soon is JSX support in Rollup. This is an outcome of one of those workshops, and we actually started working on TypeScript support, but I make no promises this will happen because I cannot promise this. But that's my goal, because the TypeScript plugin is one of the slowest plugins we have, and if we can go there, then stuff suddenly starts getting interesting. In any case, as I said, I never heard back from Avenue. Maybe he was busy doing other things, But in April, I was contacted by Patak, which is like one of the main people working on Vite itself. So one of the people, so the person who does the ViteConf conferences and so on. And he's really one of those people who gets people together and a good communicator. And they told me he had a talk with a rolldown team, and he was kind of surprised because apparently they had never watched my talk at ViteConf and didn't know what I said there. And as he said, they perceived the relationship differently. He never told me what differently was, but I had an idea, which I think, okay, so summing it up is I will keep focusing on Rollup because, I mean, it's fun. And the thing about open source is, I mean, I don't need money. If no one uses it, then it's my pet project. Fine, and if people use it, I'm happy. And it would be nice if they would talk to me if they want to align on API development. If they don't want to align, then, okay, I could also talk to them. That would also be an option. Maybe I talk to them, or we don't align, who knows. They have some ideas where they want to go. I have my own ideas. And that's it. No questions.
No, don't be shy. Okay, then does it work? Sure.
You have to. I can stand next to you and you just use mine.
Yeah. So then I have a question for you. So you worked. Well, I have actually a couple of questions. First one, like I'm not very experienced with JavaScript, but I would imagine that writing bundlers for JavaScript code is not the most glamorous part. How would you explain that there's like a whole bunch of different bundlers and people are really excited to write a new one and a new one?
That is a very good question. But I think it works like this. Like it's, okay, you see, oh, JavaScript bundling, that is super easy. You just have two files and you just put them next to each other and you're done. And then you start writing this, and do you know the sunk cost fallacy? And then they're really good at Rust, and they think they can do it so much better than everyone else, because apparently the only measurable quality that you can achieve in a short time is speed. And the thing is, being fast is super easy if you don't have any features. That's my theory.
Yes, thank you very much for the very nice talk. A part of the talk was about creating the memory representation for the AST.
Mm-hmm.
Was there a particular reason you didn't go for represent C structs and similar things, so that you could just write them into the array buffer?
Yes, there's a very reason I didn't mention. I learned Rust beginning of last year. But really, I'm open for ideas of improvement. We could have a talk later about this. Just tell me. That's actually one of the reasons why I'm having this talk. I had no idea of Rust. Most of my initial Rust knowledge was taught by GitHub Copilot. Then at some point where I thought, okay, I know the ropes, then I started actually reading the documentation a little more closely. But so another thing I recently learned about is proc macros, which is really what I need to go for, because they allow me to basically keep working on the buffer without the person writing the code needing to know how the buffer is encoded. I cut this out because I think it's really technical, and I also didn't write it yet. But at least that's my understanding. So that's actually another reason that really validates that Rust was a good choice, is that it's really deep. So really, if you have a special problem, then Rust has really some special tools at your disposal that you can use to tackle that problem. Yeah, more questions?
Okay, then I have another one. So you have, sorry.
Okay, unfortunately, it has little to do with the actual talk, but was sweating for an hour worth the reaction you got for the joke with the T-shirt.
I went to the toilet before that to put on the T-shirt. To be honest, I was waiting for one occasion to finally wear this one, because I actually got this as a present for being a speaker. So I'm kind of proud of this. Not everyone has this. Well,
okay. Then, yeah.
Yeah, sorry, I think I understood the answer, but you mentioned how everyone else is faster than you and doesn't consume so much memory, but you never actually told us why Rollup is good.
I mean, I think I read it between the lines, but could you explicitly say why I would use Rollup and not something blazingly fast, bun?
It's a good point. It could have totally included that in the talk. But then, at some point when you've been working on this stuff, it's just the bad stuff you see sometimes. But you're right. There are things I'm really proud of. So it's basically two things. So one thing is, I mentioned this at some point, but only, oh, we're back at the ocean. I let the ocean here because I think it's nice and soothing. Unless the screen, no, it will not lock. So one thing is that I think there is hardly any tool that does deeper code analysis to remove or to detect unused code. So it's a really elaborate process. I mean, that's the thing I was starting to work on when, well, that's how I got into Rollup, working on the dead code elimination. And that's also one thing that Evan Yu really wrote on Twitter at some point, that he was impressed with what he really could do, like that Rollup could, for instance, detect return values of functions that you use in an if statement and then remove the entire if statement if the content wasn't needed, these things. Recently we got one of the best contributions I ever had from an outside contributor who managed to track function parameters in a lot of cases, so that basically when a function is only called, for instance, with a variable set to true, or one of these parameters set to true, and this parameter is then used in an if statement, the if statement is simplified with this value. This is really cool. I wanted to have this for a long time, but there was no time, and he just came here, started with something where I say, okay, maybe not fast and maybe not optimal, but then I told him what I thought about his algorithm, and he completely said, okay, you're right, I can do this. He totally understood the algorithms, and in the end it was really good. This was one of the best interactions I ever had with a contributor, and I really wanted him to basically, oh, did you have a look at this problem? But then he was gone again. And so that's one thing. The other thing is code splitting. There's a lot of criticism these days that Rollup's creating a lot of small chunks, but on the other hand, Rollup is having a promise that there's no duplication between the chunks, and I think it's not possible to write a better algorithm that preserves certain guarantees you want to have about execution order. And I'm really proud of the algorithm because it is super complicated, but it simplifies everything by using big integers for set operations, which is something I came up with. And no, because chunking is all about set operations, and the problem is when you have a dynamic import, then you know that basically all the importers of the dynamic, or the intersection of all the modules that basically can import your file are already in memory, so you don't have to split them to a separate chunk. And this sounds complicated and is complicated, but in the end it makes a huge impact, and I think no other bundler does that this way. So these are the things it is good for, and if you want to bundle basically a library or something that is meant for later consumption by other tools, then I would say Rollup is the tool you should choose, because I'm not aware of a better alternative. Yeah, that's the good things.
Okay, and the last question probably.
Yeah, because I'm in the back, I guess, the last question. So, so how do you manage to do like this open source work while working at TNG, I guess, maybe on other projects while having a family?
That is the good question. The question I was waiting for all the time, and the answer is, well, so I tried different things. Working in the evening didn't work well because when I'm there, the brain is fired up, I can't sleep, so I don't work in the evening. I get up at some time between, that's kind of a crazy story, sometimes between 5:45 and 6, depending when I go to bed the night before. And then I have 1 hour where everything needs to happen, and then the family wakes up. That's how it works. That is kind of crazy. No, it's super crazy. Yes. But you're right. No, there's the family, and the family wouldn't like it if I were doing this in broad daylight. And like after 8 hours of work, I must say I like what I'm doing. There are people here from who I work together with. I really must say I like what I'm doing there. But at the end of the day, I'm exhausted and tired and need a round of sleep. So that's how it works.
Okay, thank you very much. And please, a round of applause for Lukas for the stuff.